Okay. So good morning, everyone. So in Tagalog, isang makakalikasang araw po sa inyong lahat. Thank you for joining for today's webinar. So Clarity would actually like to acknowledge DENR-EMB, especially through the leadership of Director William Conyado for this collaboration. And hopefully by the end of this webinar series, everyone will have a wider understanding in terms of both for the technology and air quality management practices. So just for a few reminders, if you have any questions, please use the chat box or the Q&A. Kung mahiya po kayong mag-chat para sa mga tanong, feel free to send me a message after the webinar and we'll try to communicate with you and answer all your questions. So sessions 2 and 3 will actually be on November 22 and December 6, respectively. We will also be sending a separate registration link for that, maybe through email. So without further ado, let me now welcome our speaker for today's session, Dr. Alex Zari from Melbourne, Australia. Alex?
All right. Hello, everyone. Welcome to the first webinar out of the 3 webinars. Thank you very much in advance for being here and for listening to my presentation. So I'm Dr. Alex Zari from Clarity. I work at Clarity as Environmental Project Manager. And in this presentation, I'm going to talk about climate change, then air pollution, and then air quality monitoring. Then we will have time for Q&A session. A bit of brief introduction about myself. I did my PhD on vehicle emission using alternative fuel like biofuel, oxygenated fuel, hydrogen. And then after PhD graduation, I worked at the emission laboratory of one automotive industry for a few years. And then I joined university and worked as a lecturer at university for a few years. And then I joined Clarity as the environmental project manager. My research area is about air quality, emissions from vehicles, and alternative fuel. So let's start with climate change, the first slide. Climate change, we know that climate change refers to a long-term shift in temperature and weather patterns. So what is the reason for climate change? Mainly is greenhouse gases. So we know these gases, CO2, methane, CH4, N2O, ozone, and etc. So how does that work? After short wave radiation from the sun, we know that the greenhouse gases, they act like a blanket wrapped around the air and they trap the outgoing long wave radiation from the Earth's surface. So that leads to an increase in the global atmospheric temperature. So global warming, it's because of that. So the sources of climate change can be from natural processes like volcanic eruption, which releases a lot of CO2 to the air, to the atmosphere. And we know that CO2 is greenhouse gases. And then it can be from human activities. We know that after Industrial Revolution, humankind started to burn fossil fuels, which that releases a lot of greenhouse gases. These are the cause of climate change. So as a result, I give you an example here. For example, CO2 increased from 280 ppm in the 18th century to 414 ppm in 2020, which means that we are doing something that increases these gases, which we are impacting the climate. As a result, climate change. So when we talk about climate change, there are some indicators and impacts. For example, if you see an increase in the ocean temperature, or if you see melting of sea ice or increase in the level of sea, or the one which is more evident is that like changes in frequency, intensity, and the duration of those extreme weather events like flooding, a storm, you should think about that, okay, there is something wrong here. It's because of the climate change. Or for example, if you see changes in our ecosystem characteristics, for example, length of growing season or timing of flower bloom or bird migrations, when you see these things, these are because of the climate change. So these are the indicators. And we know that changes in the climate can impact our health, agriculture, water supply, energy production. And most of the time, the long-term impact of climate change can directly and indirectly affect our different aspects of life. For example, I give you an example. See, imagine like people who are living in coastal cities near the area, like near the bay, for example, near the sea area, their life can get destroyed because of these climate change, which you can see in one of the example in this picture. So what can we do for that? That is the question. Response to climate change. We have two approaches, mitigation and adaptation. I'm going to talk about mitigation more in the next slide. But in general, mitigation means that we reduce the amount of greenhouse gases in the atmosphere so that, we kind of control it for the future. How can we do it? We're going to talk about it. For example, by using renewable energy sources, by burning less fossil fuel. And also, at the same time, we need to do the adaptation as well. Adapting means, we look after the vulnerable people. For example, those who are living in the sea area, which they are already impacted by climate change. We need to look after them. We need to protect them. So what is the connection between climate change and air quality? This presentation is about air quality, air pollution, and climate change. So where do they connect? What is the connection between them, which we can do mitigation? So if you look at the picture in the middle, you can see that a significant portion of greenhouse gases, which are the reason for climate change, comes from, for example, road traffic, which is the same source for the PM2.5 emission, which is a pollutant. So this is the connection between air pollution and climate change. If we look after one of them, the other one will be fixed. For example, we've got different ways of doing that. I'll give you an example. If we move from the current transportation system to clean transport by using, for example, biofuel or like electric vehicle, hydrogen fuel cell, these sort of things, we can decrease 25% of greenhouse gases emissions, which will help with the climate change. And at the same time, if we do that, that decreases 19% of PM2.5, which is one pollutant. So here is the connection. If we look after air pollution, we can look after greenhouse gas emissions, and then we can help with the climate change. So these are the things that we need to do. So here is the connection between air quality and climate change. We know that around 7 million of deaths, it's because of the global warming, air pollution, and these sort of things, which we're going to talk about it further. So mitigation is that to look after one of them, to decrease the air pollution, and that will decrease the greenhouse emissions, which will help with the climate change. So I said air pollution, the silent killer. What do you mean by air pollution? Why do we care about air pollution? I'll give you an example, a simple example that you can think about it. One adult male per day eats around 0.75 kg of solid food. Twice of that, we drink water, which is like 1.5 liter, which is around 1.5 kg. But 10 times higher than that, 15 cubic meter, which is around 15 kg of air. We inhale this air. Imagine if that air that we inhale is polluted. It's worse than the food. So we know that approximately 7 million premature deaths annually per year, it's because of the effect of air pollution. And it's not only the death, it's not only about mortality, it's about morbidity as well. So, air pollution impacts our daily life as well. Many days of, being sick at home that we can't go to work, or with kids, they miss the school. So that is why World Health Organization, WHO, considers air pollution as carcinogen. Of course, we know that the risk of getting exposure and all the amount of impact, on our health is not equally distributed between all the people. Some people are more vulnerable, like elderly people or children, and we know that it's not evenly distributed, but we need to look after that. So when I say air pollution, what is air pollution? This is the question. So air pollution is a mixture of natural and man-made, which is anthropogenic substance in the air. So there are different ways of categorizing air pollution. Those mixture which are like natural or man-made, which is in the air, there are many different ways of categorizing them because they are from different origin, they've got different characteristics, but I listed few of them. For example, the first category, we categorize air pollution by their sources. For example, if they are natural. Natural means They come from the nature, like volcanic eruption or pollen grains, or they can be because of human activities. We call it anthropogenic, like mobile sources, when you drive your vehicle, or stationary sources, power plants. Another category about air pollution is by where receptors are exposed. It can be ambient, when you go out to the city, you get exposed to air pollution from the vehicles. Or it can be from the inside the house as well. For example, heaters or gases or ovens that you use. Another category is by origin. So we've got primary pollutants, secondary pollutants. What is primary pollutant? Primary pollutants are the pollutants that they directly get emitted to the atmosphere, like CO2 or CO, for example. You drive your vehicle and then you emit CO to the air. It's a pollution. Or it can be secondary. Secondary means that they are formed in the atmosphere from primary pollutants. An example is ozone, O3. So ozone is a secondary pollutant which is formed by the reaction between NOx and VOCs. I'm going to talk about NOx and VOCs, but like there will be a photochemical reaction because of the heat and sun, and then that reaction causes ozone to be formed. So this is secondary pollutant. Another category, another way of categorizing air pollution is by the state of matter, particulate air pollutant and gaseous one. Particles, solid and liquid, and gaseous one. So these are the categories which I'm going to talk about by a state of matter. The first one, types of pollutant, particulate matter. So particulate matter is the sum of all solid and liquid particles suspended in the air. They are hazardous. They include organic and inorganic particles and dust, pollen, soot, smoke, liquid droplet. They vary in their size, composition, and origin. But how we look at them, they are regulated by their size. So we've got different particles. If you look at the picture here, it's one string of hair, and you can see the blue one, which is PM10. I'm gonna say what is PM10, and then those red one is PM2.5. You can imagine how small they will be. PM10, which is the regulated pollutant. PM10, it's called coarse particles. They are particles smaller than 10 micrometer. So they can come from mechanical process or road wear, construction, dust storm. Then one level smaller, PM2.5. We call them fine particles. They are particles which has the diameter smaller than 2.5 micrometer. They can come from combustion sources. For example, vehicles. Internal combustion engines, they make a lot of PM2.5, and they are linked to the health. So there is a fact from the research. It says that as the size of particle decreases, toxicity increases. So we've got more categories, PM1 and PM. These are the new categories in particulate matter. For example, PM, they call it ultrafine particles. They can easily penetrate into our respiratory system. If you look at this picture, PM2.5, it's the red ones, which is here. Imagine that PM1, how small that can be. So, and of course, we have a new regulation on PM, particle number. The mass of those particles called PM, which is PM10, PM2.5, PM1. The number of those particles, which are solid and liquid suspended in the air, we call them PM, particulate number. So, for example, PM was added to the vehicle emission regulation recently. And then when it comes to PM, we categorize it into two modes, accumulation mode and nucleation mode. And nucleation mode is the particles that has size smaller than 50 nanometers. Imagine how small they can be. They can easily penetrate to our respiratory system, and they can be cause of cancer. That is why we say when the size decreases, toxicity increases. And there are lots of other things. For example, in the new regulation that we are going to use biofuels. We are increasing the share of biofuel in the market, but research showed that using biofuel can decrease the size of particles. You are increasing the number of small particles, especially during cold start. I've done research on that during my PhD and when I was at university. So this is well proven fact that using biofuel makes the particles smaller. And then now we are increasing the share of biofuel in the market. Countries are using biofuel. Are we doing something good? Well, we need to do research on that. What is the reason for that? We can talk about it. So I talked about particulate matter. Now it's time to talk about gaseous emissions, gases, pollutants. So we've got different one, NO2. NO2, nitrogen dioxide. It comes from the high combustion temperature, mostly from the car. So it's a part of NOx. You've heard about NOx from vehicles. So NO2 is a part of the cycle between NO and NO2 that, under high temperature, they just convert to each other all the time. NO2 to NO, NO2 to NO, and at some point, that cycle breaks, then you will have NO2. NO2 can be primary or secondary. This is respiratory irritant, it can trigger asthma attack. Then we've got another type of gaseous emission, VOCs, volatile organic compounds, that, they've got many examples like benzene, formaldehyde, toluene, xylene, and different ones. They are, again, respiratory irritant, and some of them are carcinogenic. And the source of them, it can be, combustions, for example. We've got another one, ground level ozone. We talked about ozone. Ozone is colorless, respiratory irritant. It can trigger asthma attack, and we talked about it, how it forms. The other regulated pollutant, which is gaseous, is sulfur dioxide, SO2. So it can be emitted from the industrial processes, for example, power plants, or like volcanoes. And this is precursor to acid rain, which is something harmful. So we talked about PM, particle matter, and gaseous emission, but like when we talk about air pollution, some questions can come to our mind. I listed few of these questions here, and then I'm going to talk about each of them one by one. For example, we've got a source receptor model. What does that mean? It means that we have a source of emission. We emit the pollutant to the air. It goes somewhere. Atmosphere does something to it, and this goes to the sink. So where are the sources? What are the sources? Sources can be stationary, can be mobile. Stationary, like power plants. Mobile can be like a vehicle, or it can be natural from like volcanic eruption. So these processes, they emit pollutants to the air. It can be primary pollutants like CO, NO, or it can be secondary like ozone that we talked about. So these emissions are emitted to the air from the sources, and then based on the situation of atmosphere, something happens to them. If it is a windy day, they go a lot further, in terms of distance. If it is a calm day, something else, the way, it depends on how the environment is, atmosphere is. They can react, like we've got dispersion, transformation, and some of them get removed. So whatever happens, it happens to them, and then they go to the receptors. Receptors can be people. We breathe the air. We can be the receptor. We can be the sink. Or, it can be the air monitors that we measure the pollutant. So there is another concept that, we've got 3 questions about that, which is about exposure assessment. I'll give you an example. So you get exposed to a very high concentration of a pollutant, CO, for example, for a few seconds. That is harmful because the concentration is high. Sometimes you get exposed to a very low concentration, but for a few hours. Again, that is hurtful because it's harmful because the dose is high. So this is the exposure assessment which we need to do for how long and how much. I'll talk about concentration. What do I mean by concentration? So this is the next question. When I say how much air pollution is in the air, what do I mean by how much? How we can present it? How much connects to concentration? So for pollution, we report them as concentration. So different units for different pollution. For example, for PM, particulate mass, the mass concentration, we have microgram per cubic meter. Or we have milligram per cubic meter, depends on that. Or for particle number, we've got number per cubic meter. Or for example, for gases pollutant, if you go to the US, we use ppb, parts per billion, or ppm, part per million. Or if you go to Europe, you use microgram per cubic. And then another thing that we use is air quality index, AQI, which is technically the average of all the pollutants divided by a standard number multiplied by 100. So that's the AQI that I'm sure you have heard about. It's color coded, it's green to maroon, so you can see different colors in different type of different pollution levels. So when I said a standard, how much is too much? When I say a standard, that a standard we talked about, which is part of AQI, that tells us if the pollutant is too much or less. So each state, each country, they may have their own standards. For example, in the US, you've got US EPA And then it's like National Ambient Air Quality Standard, NAAQS. This is the standard. They use it in the US, for example. It is set by US EPA, and then it's got six criteria pollutant like carbon monoxide, lead, NO2, ozone, PM, which is PM10 and PM2.5, not PM1 or PM. And then it's got SO2. So if you go to Europe, they've got different standard. Or, for example, WHO, World Health Organization, that I'm sure you've heard about it. They've got a stricter, guideline on because they want to protect our health. So, depends on the type of standard you use, you've got different numbers. So, here it comes to clarity foundation thesis. Exposure. We understood that exposure means harm. If we get exposed, we get harm. So, but if we can, and we need to fix it. So, but if we can't measure it, we cannot fix it. That is when we are going to talk about air quality monitoring, because we want to measure it so that we will be able to fix it. So we have different types of measurement. When it comes to air quality measurements, which is very important because we want to measure it, we want to know how things are, and then we're gonna do something about it, mitigate it. So we have different types of measurement. Here we've got FRM or FEM. FRM is Federal Reference Method, FEM is Federal Equivalent Method. So these are mostly about the reference station. These are the technologies that approve. Now I'm talking about the different type of measuring instruments, for example, and methods. So there are technologies that approve legally for monitoring of those 6 criteria of pollutants, for example. And we've got some devices that are non-FEM FRM, like clarity devices that we are using. So there are air monitors that are not on the list of FEM and FRM. So I'll give you an example to, better to help you to get, your head around how things work. For example, if you want to measure particulate matter, PM, we have different methods. The first method is gravimetry. So it is technically FRM method. So we measure the weight of filter before and after sample. So we put the filter in the exhaust, and then in the pollution, whatever. So a part of like some PM particulate will sit on the filter. So we measure it after, like before and after the sampling period. And then based on the weight, we're going to understand how much PM is on that. Then we have another method, beta attenuation method, BAM. So that is based on beta rays. So FEM and FRM, they are quite expensive. They are like $50,000 to $100,000. So these are the methods that we have. And then in addition to them, we have another method. So the first one and second one are FRM and FEM. The third method of measuring particulate matter is optical, for example. So it uses a scatter, light scatter to measure the, the number of particles and their size. So it converts it to mass concentration. And the samples are, for example, clarity or green or purple air. These are the instruments that they use this technique, but their price is way less than that. Those two were like $50,000 to $100,000, but like the optical one, they are like around 1,000, for example. Depends, of course. So when it comes to measuring the air quality, we can have different approaches of measuring the air. We can use a stationary approach, we can use mobile or personal. So I'm going to talk about them one by one. But for like a stationary, it's like fixed site, those FRM monitor, those reference monitoring station that you've got it in your city, few of them in your city, they just fix on one place. Or mobile, you can put some of those monitor device like instruments on a moving car. You move around city, you measure that. And then you've got the personal one. Personal one are those small ones that, people wear it. For example, those who go to the mine, that they've got CO sensor. And, there are some disadvantages with those personal ones, which is, for example, they have unstable data. Like some human errors is connected to that. But let's talk about a stationary and mobile, these two approaches. So imagine that you are living in this city. This is your city, so you have two ways of measuring air quality. So this is your city in the scenario of a stationary and mobile. So you can see this black cloud here, which is the source of pollution. So in the mobile, you put the device in your vehicle, in few vehicles, so you drive around. Maybe your vehicle end up in those streets and you pick up the air quality. you understand, okay, something's wrong in the city, a source of air pollution is there, or maybe not. Maybe you are driving somewhere else in the city. So imagine that if you want to pick up, if you want to make sure that you know everything about your city, you need to have many of these mobile ones, which is quite expensive, laborious. And then also imagine that you've got few stations. If you want, you can see that, for example, in this scenario, you've got like 30 reference monitor stations that some of them are green, means that nothing's happening in the city. City is very calm and peaceful, no problem. Or some of the monitors, they are showing red, means that they pick up the source of pollution. So if you want to go for this scenario, 30 reference stations, each of them 100K, more than $3 million just to buy that, and then you've got the maintenance every year and these sort of things. So it's quite expensive. What can we do? What is the solution for that? This is very important. Now we are facing a scenario in our city, but do we have enough budget to do that? What is the solution for that? This is not about your city. This is about all the cities in the world. So researchers, companies, and governments, they come to the point that maybe there is a solution for that. They can go for a hybrid network. How do they do it? They use some reference stations that they have in, 3, 4 of them in each city. In some of the cities more, some of the cities less. You've got few reference stations in cities. Then you mix it with those low-cost sensors, those that are a bit cheaper. And then you mix these two, and then you come up with a model, with a hybrid monitoring system in your whole city. So you look after everything in your city. You know what's going on in your city by not spending too much, by having many reference stations that are FEM, FRM, quite fancy, expensive ones. Anyway, so you can come up with this model. So this is the current trend in the market. For example, 73,000 ambient air sensors, they were installed in 2020, and then around the world, in different cities around the world, because they want to know, governments and different people, they want to know what's going on in the city so that they look after the health of people in their city by looking after the air pollution. Or like 315,000 air sensors, they are expected to be installed by 2025. So this is the trend in the market that we know that it's increasing. And we know that cities are going for this hybrid model that is not very expensive, but they can monitor everything in their city. So as an example, with clarity that we used it in 70 countries around the world. For example, in Australia, where I live, we have like more than 400 sensors in 2 different cities. For example, in Perth, that was launched last week officially, we have more than 200 sensors around the city, and then we measure the air quality around the city. So people can go and check the air quality in the street that they live to make sure that the air is clean. So when it comes to using those low-cost sensors, when it comes to using a different sensor apart from FEM and FRM, we call it non-FRM, 2 parameters are very important. So when they give you a new device, you need to look at 2 important parameters, accuracy and precision. Accuracy means that the result of your device, the non-FEM FRM device, should be similar to your reference station, FEM result. Precision means that if you have few of the new non-FEM FRM devices, they should show the same thing. So show similar result. I put together, these few graphs, few pictures here so that I can give you a better understanding what do I mean by accuracy and precision. So you see this yellow dot, which means that the result of your reference station, this is what your monitor should show. So imagine that you've got 4 new devices, non-FEM FRM, and they put it beside a reference station, you are measuring the data from that, and then if those 4 devices, they show the same thing as reference monitor in the yellow area, they are accurate and precise. If they are showing the data here, they are precise because they are showing the same thing, but they are not accurate because they are, they have weight here. So we can do calibration to bring it here. So calibration can help here. Or here, if they are near the yellow area, means they are accurate, but they are not precise because they are here and there. And then the last picture is just they are everywhere. They are not accurate and precise. So when it comes to air quality data, And this sort of thing, we can do that. For example, in a study that we did, Clarity did at Paris, we put 18 Clarity sensor in one reference station, we measured the air quality, and here the result. You can see it visually, that all Clarity devices and reference stations, they are showing the same thing. They are showing, they are accurate and precise because they are showing similar sort of thing. So, but that was visually, but when you want to look at things from a statistical point of view, you've got 3 parameters that are important. When it comes to accuracy, let's say you've got one reference station, which is gold standard, expensive, $100,000. It measures everything perfectly. And then you want to compare your device, the new device you have. You need to look at R-square, which is Pearson correlation coefficient. It ranges from 0 to 1. The one, like it goes toward 1, it is better. Then you've got mean absolute error or RMSE, which root mean square. That looks at the difference between what you read with your new device and what the reference monitor says. So if you look at these 3 parameters, it tells you if the device is good or not. So next question that we had, who wants the air quality? There are different people that they want to know about the air quality. For example, regulators, EPA, US EPA, or researchers. People are doing research in health and medicine. They want to know what's the correlation between air quality and disease, or policymakers, or concerned citizens and industries. So what kind of data we can provide? We can give them, it depends on the purpose. For example, how frequently should we monitor the data? Yearly, monthly, daily, real time? So as I said, it depends on purpose. For example, combustion research. I was doing internal combustion engine research a few years ago, 10 years ago, and I was looking at 10 hertz data, 10 data points per second. Then I joined the automotive company. I was doing vehicle emission regulation test. I was looking at second. I had a PhD student, he was working on Poland, so we wanted monthly and yearly data. So as I said, it depends on the purpose. Regulations normally hourly, daily, and yearly. So when and where we need the monitors to be? Again, it depends on purpose. For example, if you are doing the human exposure study, then you need to put the monitors around the school, parks, offices, and homes. So it all depends on what you are going to do. And yeah, thank you very much. It was like my presentation, and we've got time for Q&A session. The next session is on 22nd of November next week. We've got 3, as Etel mentioned, we've got 3, we were a series of webinars. We've got 3 and then the second one is about air sensor network design, which is on 22nd of November. And the email will be sent, or you can scan the QR code. Thank you very much all, and yeah, we can have some Q&A session.
Alex, I think there is a question from Ray Tejada. So biofuels are introduced in the market for a decade. I think it's for over a decade now.
Yeah.
What are the effects of biofuels in the environment and in human health? Does biofuel contribute in the increase in air pollution?
Yeah, so that is a very question. Thanks, Reynaldo, for this question. Well, there are like different aspects. In general, when we are using biofuel, we've got different types of questions. We've got different types of pollution. For example, it is proven that when we use biofuel, NOx increases. It increases NOx because biofuels are oxygenated fuel. They've got oxygen inside the oxygen molecule inside the fuel. So when they get burned in the combustion, the maximum in-cylinder temperature during combustion is so high, and the maximum in-cylinder temperature has a correlation with thermal NOx, so that increases NOx. So we know for sure that biofuel increases NOx. At the same time, biofuel decreases particulate matter. Why? Because it has oxygen molecules. So we know that for combustion, we need the oxygen, we need heat, and because of that oxygen, which helps oxygen molecule in the biofuel, it helps the combustion. So it helps with burning more, more of the fuel. So it decreases PM but it decreases PM10 and PM2.5. Based on the research that I have done, and many other researchers, of course, I can refer to my papers. Yeah, using biofuel increases the particle number, increases the small particles. I mentioned about nucleation mode particles, which are the particles less than 50 nanometers. So that increases a lot, and it is well proved that using biofuel increases those particles in nucleation mode, especially during cold start. When you do, when the engine is cold, those particles are quite high, especially with biofuel, if you compare it to diesel, for example, because biofuel, they have got more VOCs. So when you've got the cold start engine, because of the cold temperature, we've got a phase change, we call it supersaturation. So some of the VOCs from gas phase, they get converted to particles, to particle phase. Those nucleation mode particles, they go up. But the problem is that we don't measure it. Why they say that they are clean fuel? Yeah, from some aspects they are clean, no doubt. But I have done a test on that with like human lung cell, and we saw that they kill more human lung cells. So I took human lung cell, put it under the exhaust of biofuel. We checked the toxicity, and then we saw that okay, now this is not better than diesel at different stages. I'm not advocating against biofuel, no. But we need to do more research. Why is that? I tell you something. In the regulation, the most recent regulation we have, Euro 6.2, which is the recent one that they are using in Europe. Like in Australia, we are still in Euro 5. In Philippines, maybe you are Euro 4. But the regulation only measures particle above 23 nanometers. Only solid particles above 23 nanometers. They call it PMP, particle measuring program, that they have it. In Euro 7, which going to be into effect, in few years, they are going down to 10 nanometer particles. So they are going to look at those small particles, and that will be the time that they're going to figure out that those small nucleation mode particles, they are increasing. And that will be a problem for automotive industry. Why they were saying that they be decreasing particles? Because we were not measuring it. And this is the gap that, industry is doing something. Researchers at university, they are doing something else. I was at university before joining automotive industry, and I was looking at small particles. I knew that. When I went to industry, I saw that, okay, they are not measuring it. That's the thing. And then if you look at the sub 23 nanometer particles, you can see a lot of information. Sorry if my answer went a bit long, but I just try to explain things. I hope I could answer.
Thank you, Alex. So we need to catch up in terms of monitoring, not just for PM10 and PM2.5, but also for ultrafine particles soon.
Yeah.
In preparation for the wide adoption and the use of biofuels and all other alternative fuels. Okay, another question. Does hydrogen sulfide from geothermal emission also affects air quality?
Well, I cannot, certainly answer that. There are some, articles, they say it does. But, I don't know, to be honest. Maybe Ethel, you can answer that, but I don't know. There are some articles that, say that.
But it will definitely have a health impact if on high concentration.
Yeah.
Okay, and then another question. A cloud of white smoke is very visible from a factory. Ordinary people who see the white smoke would automatically conclude that it is contributing to air pollution. Yet, upon stack emission testing, results show that the smoke is not pollutive. May I hear your opinion with regard to this situation?
Yeah, well, we've got two things. We have contamination and pollutant, two terminologies. Contamination is the substances, like in the air, which are above the background level. So if the amount of substance go up, that is contamination. Pollution is those contamination which are harmful. So that's the thing. When you see something on the, yes, definitely they are contamination. That's why you can see it. When the air is not clear, I mean something is there. Those clothes from factories, definitely. When it is visible, those are smoke, white smoke, definitely they are contaminations that you can see it. But if they are harmful, we call them pollution. But how we can check if they are harmful? Well, you said that, they did the test, the results show that those smoke are not pollutive. Well, from what perspective they looked at that? How did they measure it? We talked about, 6 regulatory measurements. Yeah, they checked CO2, maybe there was no CO2. They checked CO, for example, there was no CO, which I don't believe it. Well, then they checked PM, there's no PM. Like, are they sure? What, they showed the result that, okay, they are not pollutive. But like, what pollution they measured? As I said, for example, PM, we've got 1,000 compounds in PM. Which one did you look at? Did they check all the VOCs? Are we able to check all the VOCs? Did they check, that's the thing. You need to see in their report, in their result, what pollutants did they check? So we've got few regulated pollutants. NO2, PM 2.5, PM 10. Maybe did they check PM1? Did they check PN? Or we've got SO2. And then we've got some non-regulatory pollutant. So these are the things that you need to look at their report to say, okay, did they check that? Or that's a thing, it's like that biofuel discussion we had. They did not measure PM1, they did not measure nucleation mode particles, and they said it's clean. If you don't measure it, how do you know that it's clean? So that is my comment on that. I'm not going to say that they are pollutive or not, because I haven't seen their result. But when you see such result, you need to see what pollutant did they check, so that they said it is clean. Oh, yeah.
And also sometimes I think the water content of the emission is also affecting the color of the smoke. Yeah, and then
I think
seeing
Ryan wanted to answer that one.
Ryan, I'm seeing one person raising his hand, Arnold. Ryan, can we allow him to talk? Okay. Okay, so he just said this question. What extent of air pollution does smoke emission from a two-stroke engine contributes?
All right, that's a good question. So, well, it depends on the size of engine, yeah, and it depends on the type of the engine. So we've got different regulations. Like when you say the engine, is it like a Euro 1 engine, Euro 2, Euro 3, Euro 4, Euro 5, or Euro 6 engine? So one engine, when it's connected to the after treatment system, it will be Euro 5 engine, for example. Euro 5 vehicles, they must have after treatment. For example, when you talk about pollution, smoke pollution, like a smoke in Euro 5 and Euro 6 is more toward PM and PN. We don't measure like a smoke in Euro 6, for example. We measure directly PM, solid particle above 23 nanometer, and PN, particle numbers. So it depends on what type of the engine is that. Yes, two-stroke engine, they are big engines mostly, they use it in ship emissions, and technically they are not clean. They've got a big portion. For example, when it comes to ship emission, I've done it. Maybe it's good to talk about that a bit as well. Like, I've done a research. Some citizens in Melbourne Harbor came to me, and when I was working at university, and came to my research group and said that, okay, we feel dizzy. They live beside the harbor near where ships are, and then they said we don't feel that the air is clean. But there's no regulation on that. Yeah. Then we took the instruments we had and we went to their houses and put the devices there, and we saw that, okay, there are a lot of emissions coming from ships, from those two-stroke engines, and they have a big contribution. And I think now in terms of internal combustion engines, I would say like for heavy duty and light duty, they are getting paid because of the electric vehicle, and then now is the hot topic about ship emissions, which is from those two-stroke engines, because some of them, they are still using heavy fuel oil, which is like dark. If you see those heavy fuel oil, they are like quite dirty, to be honest. And then, well, when you compare it to a Euro 6 vehicle on the street, and then you compare a ship with that, well, it's like one ship equivalent to thousands of those vehicles. And that's how bad they are. And now people are doing some research on ship emissions. It's a hot topic area these days. I hope I could answer the question.
Arnold, are you satisfied with the answer? Or are you also referring to, because I think Alex, here in the Philippines, we have motorcycles. Is that what you are referring to, Arnold?
Maybe that two-stroke engine, he meant motorcycles.
Yeah.
Well, if the number of those motorcycles are high, yeah, definitely. But again, it depends on what type of regulation you are using in Philippines, like Euro 4 in Philippines. So when it comes to like, based on the regulations that you use, these engines, they have to have after treatment system. For example, for PM, they use particulate matter filter, which is like if it is diesel or if it is petrol, you know, we've got GPF and DPF. And then in terms of NOx, they have like different things. For example, you know, they use NOx lean trap, LNT, and then, you know, they can have different after treatment systems to, you know, look after emissions. But yeah, I mean, from the empty engine without after treatment, that can be a lot. It depends on how many.
So I think Arnold is okay with their answer. So any other questions? You can also raise your hand if you don't want to type in your question, and then we could allow you to talk. Okay. Going once, going twice. So no more questions. If you have any other questions, feel free to reach out so we could possibly give you a more detailed explanation. And if some of the questions earlier, you want a more detailed explanation, especially for biofuels, vehicle emissions, because I think, Alex, that's your specific topic that you know more. You can send us those questions and we will try to address it in detail. And then
just to clarify something, that I am not advocating against biofuel. It's just, you know, it's a research area that people do it. You know, I've done research on that for like 10 years. And yeah, there are some, you know, gray area around biofuel, and which, you know, at the same time, everything has trade-off. It's got some advantages and disadvantages, which, you know, at the end of the day, decision makers are the one who decide which one, you know, weigh more in terms of that trade-off. So yeah, different perspective of looking at using biofuel. But the thing is, the fact is that it's a current trend in the market.
Yeah.
Yeah. Sorry, Ethel, for interrupting. Yeah.
Especially in Southeast Asia. So the use of biofuels and alternative fuels. So we will be sending a link through email and chat, I think. It's for the feedback form. So please accomplish that on. And then for the next session, which will be on November 22, that will be on next Tuesday, same time, 10:30 to 11:15. Sorry. Yeah, we are over time already. Please register again for that session 2. And then we also send the link for the last session, which is on December 6th. So thank you again for attending. I hope you all learned today something new. I have a lot of learnings in terms of biofuels and the possible trade-off in terms of adopting to this kind of cleaner fuel. So thank you, Alex. Thank you, Ryan, also for assisting. And again, we would like to acknowledge DENR-EMB for collaborating with Clarity for this initiative. So have a good day, everyone.
Thank you.
Thank you, Alex.